Welcome back, everyone. On to the third session of our Skills Canada Saskatchewan microbit and Inksmith professional development session, things, whatever we want to call them. In the first session, we went over some of the basics of how to upload things onto the code, or upload the code onto the microbit. And in the second session, we went over some sensors. Well, I want to take some time right now to actually run through an activity that we could use here. Now, I don't have anything formal written up or typed up about this, at least yet. Could if we need to. But I think this is an activity that can happen in many classes for many different reasons. We could be doing all sorts of different things, but this activity, a very basic starter activity with some really important extensions onto this, I like to call, where should I put this plant? A very simple question I'm sure we've all had throughout our lives. We get a plant and we figure, where should we put it? Now, this takes into account a lot of different things. You know, we need to know what type of plant we are, what type of temperatures it likes, what kind of light it likes to have. And knowing that plant and knowing what type of light it likes, what kind of intensity or direct or indirect light, or what kind of temperatures it likes, that can actually lead us into thinking about, why can't we use the microbit to make these decisions? Why can't we actually program something so that we can compare various locations? So that's where I want to start today. For this activity, all we need is the microbit. We will need our battery pack and our USB cable. We're going to start at the very basics, creating a new project area here. And for this guy, I really want to just measure the temperature and the light. And we could run this as a class activity in a few different ways. The first way that I would run this, just me personally, is I would simply get a microbit set up. We push one button to read the temperature, one button to read the light levels, and record this data for a few days over the span of the day at a few different times. So that's what I'm going to start with, very basically. Again, on start, I'm going to just make it say hello. Very simple. That just lets us know it's on. On the forever, I might put maybe an icon on here. Just so that I know it's running. And maybe I'll do the two icons so that we go here and here. Maybe even a third icon to go. It might be bigger than that one. Or maybe even just the two icons, so I know it's going boop, boop, so that we can clearly see it's running. I think, I don't know about you. To me personally, I like to know that this is running if I'm going to be having this data, so that I know the batteries aren't dead. That's the big thing. And then I'm going to have this very similar to what we did in the last session. We're going to have on button A pressed, and we're going to show the string T equals And then we're going to show string for the temperature. And I'm going to duplicate this and do the same sort of thing, except instead of temperature and button A, we're going to put button B. We're going to put L equals, and we're going to use a light level. Now this would allow me to then take this and put this in different locations, have each student kind of pick their own location maybe, and have them record their temperature and light level data at various times in the day. This is where I would start. Now I'm going to load this up. I'm going to put this guy on and just show exactly what we're going to do. So again, let's download this guy. We will look into our downloads and onto our microbit. Take this section 3 and move it over. Give it its time to do its running over. And now we have, now we have a very important tool that we can use. And you might say, well, yeah, but it's still connected to a computer. Well, if I take this, connect it right onto this battery pack now. And now I have a full little device that I can plant and put anywhere I want and record different data from it. So now I have this little device. I can take, maybe I have one student put it right in the window, one student put it in a corner of the classroom, one student put it next to the window but out of direct light, and we can record the different things. So I started with T equals 25 degrees. So that's what it's reading in here right now. The light level, let's see what that says. L equals, oh, that went to different one. Oh, 186. See, 192 or 198, sorry. And see, we see these different recordings. Now you'll notice here, when I do this, it's kind of weird because it's not always just going L equals, it's going to work just like that now. But it might actually show a little different thing here. Like that just went right to the number. That's a coding little nuance. We can change this whole thing. So instead of it flashing back and forth, it's just going to have a blank screen. The key is knowing which button means which. So this is T equals, again, should be about 20 something. And as I get higher, I'm going to go way up higher to a light here. This number gets higher. I'm going to turn off the direct light on it, and it should get a little lower. So our L equals 158. What if I cover this entirely? We're going to get a very low number. Oh, I got right to 0. So if there's no light there, it'll just say 0. And we'll have different values here. Now, there is something about that that is bugging me that little bit. So I'm going to go back here. I'm going to take out these guys in the forever. And I'm just going to have it so that when we push the buttons, it just does precisely that. And that was because we're running into that little issue where it's not necessarily going very nice and smoothly. It's not displaying each of those things. So I wanted to change that. I'm going to make that little change here. Drag this guy over. And now we'll see a variety of things. Now, you could also have different students, or each group of students, check 6 or 7 different groups of areas here. You could have them start in one area of the classroom, perhaps right next to the door. You know, we can say, well, what's the temperature near the door? And what's the light level near the door? And then change to a different location and have them record all of this information again. That way they can plot their different information based on where they are, and they have all of their information points. You can encourage them to take multiple points of data, you know, and talk about the scientific records and all this stuff. You could also have them do this at multiple times throughout the day. So take 5 minutes in each class at each hour and have them record some data. And that works just great. This would then allow us to kind of plot out and see which area of the room has the most light, the least light, the higher temperature, the lower temperature, all sorts of things like that. And that works pretty well for determining where your plant should be. I mean, you could use a setup like this and determine where you want to put your plant based on your class. Now, is that sufficient? Well, it depends on your class and what you want to run it as. For me, if I'm doing this in my class, I'm not going to leave it at just this. I'm going to want to know more of a temperature range that it will hit throughout maybe a day or 2-day period, and a temperature range, so temperature range and light range over a period of time. So we have to really think about what we want to do here. When it gets to this point, it's what do we want to do and how do we want to do it? So I'm going to bring out just a little notepad, and I'm going to start with what I want. So I want to know the light range, which means I need to have a top and a bottom measurement. I want to do the same for temperature. And I have to think, how can I actually record this stuff? How can I sit here and sit back and say, okay, how can we store this information so that we can access it? We already see how we can actually just, you know, measure the light at any time. But how can we know what the maximum is over a 24-hour period or a 48-hour period or whatever period we want? So we have to sit back and we can think about this. Well, I'm going to start by looking and saying, listen, this top needs to equal whatever that highest measurement is. Now, we can take a look at this and simply say, if this highest measurement, let me quickly just, but if this highest measurement, if this variable isn't this, well, then we simply replace this guy, right? So if we take this top measurement and it is this higher measure, this highest measurement, then we're good. But if this top value that we put in is not the highest measurement, well, that means that we've measured something that's greater than this top value. So we need to change the top to that highest measurement. So now we're thinking into some logic and some math here. And this might sound a little scary. It's okay to be a little scared with this, because we also want to do the same thing with the bottom, right? If the bottom is the lowest, we're good. But if the bottom is not the lowest, then we need to change it. To whatever that lowest measurement is. So how can we do that in a programming language? I mean, when we're talking in terms of human language, it seems pretty easy, right? If we have this top value at 20, say it's 20, but we have a measurement that's 25, well, then we simply just make that top 25. If the top is 25 and the measurement is 3, well, 25 is still greater than 3, so we can leave it at that. So this is where things get a little bit tricky when we're talking about logic in programming. This is where I would take an advanced step here. I'm going to just move this up here and just look at what I mean and how I'm going to take this function. So we're going to start with the top equaling whatever our measurement is. And we're going to talk about that being the first measurement. So we'll set that equal to the first measurement. And then we will compare. We're going to compare the top to the next measurement. We're going to compare this top to the next measurement. If the top is greater than or equal to that next measurement, then we just leave the top alone. If this top happens to be less than that next measurement, then we need to reset this top to whatever that next measurement or the new measurement is. And then we can repeat this process over and over again. So we first set our top measurement to whatever our first measurement is. That's going to be easy. And then we compare it, the top to the next measurement, the top to that next measurement. If it's still greater than that next measurement, we leave it. If it's less, then the top has to change, because the top has to be that maximum value, right? We do the same thing for the bottom. Again, we set the bottom equal to that first measurement. And I know you might be saying, well, but we set the top equal to that first measurement. How can we set the bottom equal to that first measurement? But for that first measurement, that top and bottom are the same value. So we're going to just set the bottom equal to it, and then we're going to do that compare again. Now, I know this might sound a little odd, and it might sound like it's going to get really confusing and difficult. But that's why I'm drawing this out. Because once we have it drawn out, we make it easier to see. But we'll look at this. With this bottom, if it is less than or equal to that new measurement, then the bottom stays the same. But if it's greater than that new measurement, then the bottom becomes that new measurement, right? If the bottom is bigger than what our new measurement is, then we have to set our new bottom measurement. I hope this is making some sense. I don't know if it is or not, but I hope it is, because I'm going to take this mentality and apply it first to our temperature, then to our light range in here. So we're going to first change this button. We're going to get rid of that for right now. We are going to need a couple of variables. I'm going to say max temp for the maximum temperature and the min temp for the minimum temperature. That's where we're going to start with this. And we're going to simply set each of these guys in the start to a certain value. And we'll get to that here in 1 second. Now, what value are we going to put in for these? Well, that value is going to be whatever the temperature is right now. That's all this is going to be. Oh, I don't know what I just did. Whoopsie. Let me see what I just did. I'm going to get out of here and go back into session 3. Here we go. Not sure what happened there, but the first thing I'm going to do is simply set both of these temperatures, or both these variables, to whatever the temperature is right now. Now, over here in this forever, we need to start using some things called logic. Now, this is where we actually do the comparisons. We're going to take a look at these things called if, then, else statements, or if loops, or if conditionals. So what we're going to do is I'm going to start here. We're going to change this true into a comparison. And this comparison is where we're going to put our variable. So we're going to start with, oh, where are we here? This max temp, just like we did here. We're going to take a look at the top, that max. If it is let me move this guy here so we can see it right in the center. If the max temperature is, what did we say? Greater than or equal to the temperature, then max temp doesn't change. So we can literally just simply say, just for clarity's sake here, we're going to set max temp to max temp. That means we're going to leave it exactly with max temp to max temp. But we're going to add something here. Now, I want to change this to another if. And this is where I want to go to put the second part in. So again, with a logic and with a comparison. If this max temp is now less than this temperature, then we're going to set our max temp equal to whatever that new temperature is. I hope this is making sense now. So all we've done now is we're doing this comparison to see if the top temperature is still greater than or equal to the temperature. And if it is, we're not changing anything. If, however, that top temperature is less than the new temperature measurement, we're going to set that temperature equal to that temperature here. I hope that makes some sense. Now we're going to duplicate this whole thing, add it down here, except we're going to change this from max temp to min temp. And instead of being the greater than or equal, we're going to go with the less than or equal. And we're going to set this with min temp and min temp. And now if it's greater than, is that the right way we have this? Yeah. And now we have this whole process done for actually storing our temperature values and storing our temperature ranges. Now I know it seems a little bit big here. I'm going to zoom out just a touch so we can see this a little bit easier. So we started, it says hello. We set our max temp and min temp to whatever the temperatures are. And then we change this. Now, what does that really tell us for any of this? Well, now is where we can actually start listing out and reading our data. But before I do that, I don't want this to be continuously running. I'm going to put a pause in here for, I don't know, 5 seconds. So it's going to do this comparison every 5 seconds. If we want this to be maybe every 5 minutes, we just have to change this from 5,000 milliseconds to whatever we would need for 5 minutes in milliseconds. I'm going to be fairly okay with the milliseconds, so that's fine. And now I'm going to say on button A, press, we're going to show some strings, and I'm going to duplicate this guy 3 or 4 times. And I'll show you why. We're going to put these strings in here. So here we will say max temp equals. Then in here, we're going to put our max temp variable. And then here, min temp equals. And then we'll put the min temp variable there. And we'll compare this here now. Now I'm going to use just this guy here for right now. If we show A, it says max temp equals 21. Min temp should also equal 21. It just says there is no difference there. Now we're going to run a test on this. I'm going to bump this up to 38. I'm going to wait a few seconds to make sure this goes through once or twice. And now we'll change. See what happened to the max temp. Max temperature equals 38. the min temperature should still say 21. And it says 21. So what we've done here is we've now created a device that can capture a temperature range. This could be very useful if we're looking at putting plants in a classroom or anywhere during, oh, maybe we want to plant in March, but we need to know that the temperatures are going to be within a certain range. So where can we plant them? Or maybe we have a plant that doesn't like super high temperatures, so we need to know what the max temperature will be. Running an activity like this focuses on a few things. One, it focuses on the actual learning of the planting specifics, the ideals. It then also focuses on learning some comparisons and learning some logical flow. Now, we could do this exact same thing with the light range. If we simply, I'm going to duplicate all of this stuff here. I'm going to create a couple new variables. Instead of max temp, we're going to say max light and min light. So I'm going to change all of these guys over here. Just click right on the drop down. Max temp, we're going to change to max light. Min temp will change to min light. Min light, min light, min light. And the only other thing we have to do is change this temperature from temperature to light level. So we can delete that temperature. And we're just going to take this light level. And light level. And one more light level. No, two more light levels, I think. Light level there. And light level there. And I'm just going to put this all right in there. We can delete these temperature guys here. So I put the light level down there. Now, instead of on button A pressed, maybe we do this button B pressed. And we're going to show max L and min L. And here we go. Now we have a device all of a sudden that we could plant for a day, 2 days, 3 days, 4 days. And it would tell us the temperature range and the light range that it experienced for however long we want to put it in there for. Maybe that's a day, maybe that's 2 days, maybe that's over a weekend if you really want to see how well your plant could survive there. And again, it's comparing this stuff. It's that comparison, making some logical statements there, making some logical decisions. But again, it only uses the one little device. I'm going to put this onto my guy now. We will download this. And I will bring up my downloads and my microbit. I will drag this guy over. Give it a minute or two. And the only thing that we have to worry about here now, and that's the key part here, we need to make sure, so we can unplug this guy, and we just need to make sure we don't forget. We press this here, it says our max light is 196. Our min light is 0. It's weird. We didn't go through 0 yet. Oh, it still says 0. That 0 seems a little weird. I'm going to check back at the code here. Make sure I didn't mess anything up here too bad. Oh, I see. I see what we didn't do. So we did miss something here. See, we didn't set an initial value for this max and min temp. So it just held that 0 value, which means we have to set our max and min values right here before we get this guy going. So the max light and the min light, we're going to set those guys to light level. See, it's not a problem. See, we can all mess up here, and that's all fine. There is one other thing I want to do here that I'm just noticing from here, is that this guy is just reading and listing a 0 there. I'm going to want to put a clear string here, or clear screen. So it just clears everything once this is done. Okay, now let's plug this guy back in. We're going to download this new guy. And here we go. Boom. And let's see what's different here. I think this is an important thing to point out too. If a mistake happens, it's okay. We all make these mistakes. Even the best and brightest will make these mistakes. I mean, I have a lot of experience with this stuff. Made that little mistake there. So let's see what it looks like when it's fixed. So max L equals 192. Min L equals, should also say about, okay, so 186. What about our temperatures here now? Our max temp equals 26. Must be really warm in here today. And min temp equals 25. Okay, now I'm not going to be able to do a whole lot to change temperature in here right now, but I am going to just cover this light and see how it changes this. So we're going to cover it for about 5, 10, maybe 15 seconds. So it gets that new reading. And then we'll put this on and we'll check, see what it changed. So the min light was at 186. Let's see what the max and the min say now. So our max L is 193. And the min L is 0. It went right down to 0. So when we covered it entirely, it went right to 0, which makes sense, doesn't it? It should make sense with that if it's covered. So we know this is working now. If I was going to decide to plant or put a plant into my classroom or run an experiment, I would get my students, or if I was planning on having my students plant something, I'd get them using something like this. With the level that I have my students at, we're at the high school level. I would expect them to be able to do the maximum and minimum values so that we could get that temperature range. I might even ask them for some more advanced things, like maybe instead of just that temperature range, I want to know what the average temperature would be, or something along those lines, where they would have to think about an algorithm and develop a mathematical formula to program onto here. I may also look at them and say, okay, we need to design a plant holder in different locations. And this would be the start of where we would start with that. We would look at the light levels, the temperature levels. We might add a few other sensors or things here, but this is where we would start. Now, if I was doing this with an elementary class, I might not really be concerned as much about the temperature range programming and all that thought, but getting the various data points is pretty key here. Again, when you use these things, this is just the basic device and an idea for how to use it in a classroom. There are other ways, and I'll show you some more as we go along in the next session. This was just one way that I would do in a class where I want to grow a plant. As part of a science activity, or growing activity, or even a design activity, we can design the planters. If we wanted to get more advanced, we could add more sensors in here and keep taking it from there. I mean, the sky becomes the limit there. This is just an idea for how we start. Now, this was using the temperature and the light sensor. We could also take a look at using an accelerometer for something like an egg drop, or, well, really anything. There's compass directions in here. There's magnetic field, guys. There's a lot of different ways these can work. I hope you've learned a little bit and saw some ideas in here. And I apologize. Some of this might be a little crazy, especially when we're looking at getting into the logic and some of these comparative measures. Yeah, things get a little bit longer and crazier. And the first time we go through it, it might look really confusing. But really, all we're doing here is we're just comparing this maximum variable to whatever the measurement is. If the maximum is bigger than the other temperature, then we don't have to update it. If it's not, then we have to update it. This is a device that I would probably use in my classroom if I was starting with some planting, or in a horticulture type class, or anything. Even if you're talking about keeping pets in class, you want to maintain their environment for fish. Maybe you want to know that they're not getting too much light, or the temperature is good, or a reptile. There's all sorts of different things that this sort of thing can be used for. And this is just a recording instrument here. We could also set this up so that maybe we want to ensure the temperature is within a certain range. And if it's outside of that range, we want to send an alarm. Well, that can be done here too, right? We're just reading the temperature. And if the temperature is outside that range, we're going to play some music, play an alarm. All of these are wonderful ideas here. I hope you've kind of looked at some of this and said, man, okay, we can start getting into some of this. We can start playing around with it. I know it seems, and it might be really like a lot right now. Start with the basics, start using and utilizing some of these and playing around. Get comfortable with them. Expand on this. Like I say, for me, if I wanted to do this with some grade, I don't know, some high school kids, and we're looking at long-term temperature plans or long-term planting plans, I'd also want to check and see the average temperature. So I'd have them develop their own formulas for that. Even the developing how to do the max and min temperatures, I'd have them think about that and develop their own algorithms for that. In a younger year class, I'm probably not nearly as concerned about some of those algorithms. Much more concerned with them being able to use this and read some data from it and then what it can tell us. And again, I'd like to point out one more time here, this is just using the microcontroller or the microbit. Just that single device. We haven't added any other sensors. We haven't added anything else. This is all the built-in capabilities here. Now, for our next session, I have one other activity that I want to do just purely based on this guy, which I would use in maybe a couple different classes, maybe a phys ed class, or maybe a mapping and cartography type activity, or a treasure hunt type thing. I want you to think about, how could we use this in a treasure hunt? I have an idea for how we could use this to find different treasures. And that's what our next session is going to be about. I hope you've enjoyed this. I hope things are making sense. And I implore you, if something isn't making sense, or you need something explained a little different, or you just want to talk and figure out some ideas, please reach out and contact me. I'm always more than willing to help out and throw some ideas around. Until next time, have a good one.